Hi, my name is Alison Jean from the Empathic Computing Lab of the University of South Australia. I'm here to present our work titled eyemR-Talk, Using Speech to Visualize Shared MR Gaze Cues. In this poster, we present eyemR-Talk, a mixed reality collaboration system that uses speech input to trigger shared gaze visualizations between remote collaborators.
Can you look over at this one?
This one I'm looking at.
The local user in a physical task space wearing a HoloLens 2 AR-HMD can interact with the immediate surroundings. The remote collaborator wears a Vive Pro Eye VR-HMD can view the shared scene and exchange interactions with the local user. Both AR and VR HMDs have built-in eye trackers to capture gaze data, and we use Windows speech recognition to detect voice input. The user views are independent, shared via Live 360 panoramic camera, Theta V. To share gaze cues between remote collaborators, we designed 3 shared gaze visualizations based on gaze behaviors. They are brow state, focus state, and joint state. Brow state is for active eye movements such as saccades or shifts, showing a single cursor in blue. Focus state, if the user's gaze dwells for 500 milliseconds or more, a double ring cursor is shown in yellow. Joint state, when the 2 collaborators' gaze overlaps, the gaze indicators will be placed with the green cursor twice as large to indicate shared gaze locations. For the user's self-gaze indicator, it remains pink in a single cursor shape. To build an explicit connection between verbal conversation and nonverbal gaze visualizations, we use the Windows Dictation Recognizer API to inspect contextual information during task coordination. We added 6 frequently used dictate references and keywords into an input list. This, that, here, there, look, and see. When either user speaks one of the target keywords, the system guides the collaborator who receives the verbal communication to attend to the partner who initiated it. This visualization, called Joint Gaze Indicator, explicitly connects current gaze focus between collaborators. Therefore, the combination of contextual keywords and gaze cues together encourage joint gaze interactions. There are 3 different MR visualizations developed to showcase joint gaze indicators, depending on the visibility spectrum. Arrow pointer is an arrow that rotates around the user's own gaze cursor to point at the partner's cursor. Screen edge pointer, when the partner's gaze cursor is out of the field of view, a bigger arrow appears along the edge of the user's FOV to point towards the partner's gaze. Ray pointer, a curved ray links between the user's own gaze cursor and the partner's cursor to guide the user to the partner explicitly. In this paper, we present eyemR-Talk, a 360 MR remote collaboration system that uses speech input to visualize shared gaze cues in 3 different styles with 3 levels of visibility. By visualizing gaze cues triggered between conversing remote collaborators, our system connects verbal communication with nonverbal gaze behaviors naturally within the context, providing novel interaction methods to achieve joint attention and mutual understanding. Our approach is suitable for physical tasks where the nonverbal cues are less accessible, or for users where physical cues are temporarily disabled. We plan to further explore this concept through formal user studies in the future. Thank you for your attention. If you have any questions, please feel free to contact me. Thank you.